el matrimonio perfecto entre los diagramas de flujo y los algoritmos. El video tiene títulos en español para aquellos que quieran leerlo. Está bastante completo y al final pues vamos a repasar el tema. Ok, los dejo entonces con el video, jóvenes.
Hi everyone, welcome to this computer class on flowchart and algorithms. This is a very important topic because in today's class you're going to learn how to think like a programmer, how to think in terms of flowcharts, algorithms. We'll also look at pseudocode, how to write the program before you start coding. So very important class, and I'm going to make these concepts super easy for you. So let's get started. Before we begin the class, I want to say do check out the other courses on our website. We have physics, chemistry, biology and maths for CBSE class 8, 9 and 10. So guys, if you haven't taken the other subjects, do take them and do share it with your friends. For the ICSE students, once again, we have physics, chemistry, biology and maths for classes 8, 9 and 10. So do share out our courses once again. And as you know, we have these two coding courses, Python and Java. Both are very popular computer languages. So definitely you're learning the top programming languages used by professional programmers today. And we also have Cambridge IGCSE, which is the international board. We have physics and chemistry courses there. So please do share the courses on our website. Make sure you have subscribed to our YouTube channel. We also have a Hindi channel. It's called Manocha Academy Hindi. And you can follow us on Facebook and Instagram. So do stay connected with Manocha Academy and keep learning. So today we are going to learn about how we think about recipes, right? So what is your coding recipe? Or first let's start with a favorite example. I'm sure all of you love eating noodles, right? So if you're hungry, actually looking at this picture, I'm feeling hungry, but if you're feeling hungry and you quickly want to make some noodles, or your mom is making noodles, you or she follows a recipe, right? So to everything that you do in the kitchen, there is a recipe. Or if you're baking a cake, there is a recipe. So what is the recipe when you're making the noodles? Can you guys tell me? So what do you need to do here? So let's say you're making these instant noodles. So what is the first step? Obviously, you will cut the packet and boil the water, right? So we can say we open the packet, we boil the water, and then obviously you will add all the noodles in the boiling water. And then after it's mixing, now you pour in the masala, the spices, right? So it's more like a cooking class today. So then you add the masala or your spices, and you keep cooking it till it looks nice and yummy, and you stop it and enjoy the noodles. So this is the recipe, right? These are the steps that you follow while making noodles or instant noodles. Suppose when you change these steps, can you add spices first, then open the packet, then boil the water? If you do that, you won't get these tasty noodles. And especially in cake recipes, if you make one small mistake, either the cake turns out to be hard, or there's no sugar in the cake, it's not sweet. So any ingredient or any step you miss, the recipe is gone, right? So that is why, just like in the kitchen, you follow a step-by-step procedure, a recipe. Similarly, when you're writing code, what is code? Code is instructions to a computer to do something. You are giving the computer the recipe, or you are writing the recipe for the computer so that it does exactly what you want it, right? Just like exactly what you expected the noodles to taste, you get it if you followed the recipe. Or when the cooking thing goes wrong, mom will say, you didn't follow my recipe. Similarly, we are going to learn how to think about not cooking recipes, coding recipes today. So we are going to talk about code recipes today, and code recipes can be written in different ways. What is the meaning of a code recipe? So the moment you are, let's say you want to design a program, whether it's a game with rolling of a dice, or whether it's, doing some income tax calculation, or finding out, the average marks of a test, any of these things, always you don't immediately start writing the code, especially if the program is a little complicated, right? What you do is you think of what will be the steps. You break down the code into steps, and those steps need to be in the correct order. So that is what we call in informal way as code recipe. Now code recipe can be written in different ways. It can be expressed as a flow chart. You can write it as an algorithm or as pseudocode. And we're going to discuss all these three styles of recipes today. So very, very important class. So at the end of the class, you will learn to think like a coder, like a programmer, and these techniques will help you plan out your recipe before you write the code. So what we are learning today is not coding, we are learning the thinking, the planning step. So in code recipes, what we are learning is planning and thinking of the logic. And do you think this is important? This is super, super important, because if your logic is wrong, just like if the building plan is wrong, the architect's plan is wrong, the building is not right. Same way, if your logic or your plan is wrong, obviously the code will not do what you want it to do. So thinking like a programmer is very important, and let's learn these techniques which will help us express the recipe. So it's important for us and for anybody else who wants to know what our program will do. He may not know the language that you're coding in. Like for example, he may not know Java, he may not know Python. Same way here, if they look at your recipe, they will get to know even though they do not fully understand your code. It's just like, when J.K. Rowling was writing Harry Potter, she was brainstorming and thinking of the ideas, what story to write. It doesn't matter whether she wrote it in English, whether she wrote it in Hindi or, Spanish, German, because now it has been translated in all the languages of the world, right? So the language doesn't matter. It is the thought, the ideas. So same way here, it's not the coding language, it's the recipe that matters, and we are going to discuss about it. So we are going to understand what is a flowchart, algorithm, and pseudocode with a very simple example. Let's say the question given to us or the problem given to us is find the area of a circle. So we want to write, the goal here is we want to write a computer program to find the area of a circle. We'll start with a very simple example. Now when you want to find the area of a circle, what does the computer need to know? First of all, he needs to know how big is the circle. So what is the radius of the circle, right? So for example here, the computer needs to know what is the radius of the circle. So that must be supplied to it. And then you calculate the area. So the radius of the circle has to be input to the computer. And then it will work out the area using the formula. Area is pi r square. But does the computer know what is the value of pi? Computer doesn't know. We have to supply it. What value you want to use? 22 by 7, 3.14. What value you want to supply here? Usually in computers we use decimal values rather than fractions. So maybe you'll be substituting 3.14 here. So the goal is clear. We need to write a code or a program to find the area of a circle, but we are not going to do the coding. We are going to do the planning of what will the program do using flowchart, algorithm, and pseudocode. So let's take a look at, because these are all different styles of writing the logic, the recipe of the program.
This AI tool will take your idea, everything, including the content, literally in a few minutes. Watch.
So let's understand what are flowcharts. So as the name suggests, it's a flow chart, which means it is like a chart where you can see the flow of the program. So what is the formal definition of flowchart? It is a pictorial. It is a pictorial representation of step-by-step solution of the problem. So pictorial means graphical. So you can see you're sort of drawing a picture of the steps, showing it like a graph. So it is more of a kind of graphical representation or a pictorial representation of the step-by-step solution of the problem. And this is what we call as a flowchart. Now, when you're writing a flowchart, there's one interesting thing that you use different shapes or different kind of boxes here. You don't just put everything into a rectangular box, you can see there are different kind of shapes here. For example, can you see the start and stop is kind of rectangular box but with kind of curves at the end, so it looks like an oval almost. So start and stop is there, and this signifies the start of the program and the end of the program, stop. Then when you want to, whenever you want to take input, remember we said for the computer to calculate the area, you need to supply the radius. And let's say we are taking user input, what you have learned in Java or Python, you can take user input. So the input box we represent with this parallelogram kind of symbol. Okay, we don't use a simple rectangle here. We use this parallelogram to input the radius. So you can see, start, the first step is to input radius, because you cannot do first step area. If you don't know the radius, how will you calculate the area? Then, so the next step we represent, we draw this arrow. So the program is flowing like this. So you can clearly see the direction in which the program is going. Area, so you put down the area formula, 3.14 multiplied by r multiplied by r. See, now you're getting a little more computer specific because computer may not know what is r square, right? So you're writing the clear formula for the computer. So in these kind of things, sometimes you keep the computer in mind. Sometimes in the books you'll say they're simply writing pi r square in mathematical terms. So whatever convention is being followed in your school or your book, but usually we try to write it close to the computer. Here sometimes you might want to use multiplication because you know in computer the multiplication is represented with the star symbol. But for here I've ignored that detail. We have just written it as a normal multiplication. So that's your area calculation, and then finally you go to printing out the area. So can you see again you have drawn a kind of parallelogram box. Why? Because this input and output are drawn represented with this parallelogram, and any processing or any computation that happen represented with a rectangle. So clearly you can see this is the input and output steps. So this is an input step, this is an output step, and this is the processing step. And then finally you end up with the stop, where you write stop, or sometimes you might see the word end here to show the end of the flowchart. So these are the standard flowchart shapes and symbols, and when you're writing comments, you write this annotation with this kind of, line and then this kind of bracket. So these are your annotation or comments in the flowchart. We'll look at some more symbols. These are usually standardized symbols. In fact, I pulled these symbols using the, there is a flowchart tab in PowerPoint also. So these have been drawn using PowerPoint's flowchart shapes. So they are pretty much the industry standard today. And as you can see, it is a pictorial representation of the solution to your problem. So this is how you write down the flowchart. Flowcharts are very popular because it's very easy to read, very easy to understand the flow of logic, and it is one of the most popular ways of representing a recipe or your logic. So we saw an introduction to flowchart. Next, let's look at what is an algorithm. Again, it's another way of representing your recipe, your logic. So what is an algorithm? It is a set of steps to solve a problem. So algorithm is nothing but a set of steps to solve your problem. Just like we saw the algorithm for cooking the noodles, right? Step-by-step procedure. And here you list them down very clearly, like 1, 2, 3, 4, 5. Just like recipe steps, you can just write 1, 2, 3, 4, 5, or you can write the word step 1, step 2, step 3, whatever convention you're following. These are not written in stone. You might change your, you might see changes in styles in different books. So what is the first step? Again, like a flow chart. So this one is not pictorial. It's more like a step-by-step statements. So you can see start, and the ending one is a stop. Then what do you have? You say input radius, and you give your variable name here, comma r. So this is more written like, in English rather than writing the actual input statement. So like in Python, the input could be different. In Java, you use scanner. In C++, you use cin. So we are not bothered about that. We are writing it in simple English, input radius r. Next, we will say, how does the computer calculate the area? We give the formula. And typically in algorithm, you will see, rather than using equal to, they use this arrow symbol. So they are saying basically 3.14 multiplied by r is assigned to this area variable. Okay, so this is very popular. If your school or your book is using equal to, that's also fine. The arrow symbol is popular, and the arrow is from right to left. Okay, and then you go ahead and print out the area, otherwise the user won't be able to see the output. So you can say print area and your variable name A. So you can see all the variable names are clearly mentioned, and then you stop. Okay, sometimes this arrow symbol is also used in flowcharts. So you can see it's very similar to a flowchart, very similar. The main differences are we don't draw a diagram, we just write it in terms of clear steps. Steps have to be numbered, very important, because you might say now go to step 3. Just like in a recipe, you know, sometimes they say go back to step 2. So step numbering is very important, and then you write it in very simple English. You're not writing the actual code like Python or Java, because maybe your friend doesn't, let's say you know Python but your friend knows Java. So we want to write it in a simple, friendly, neutral way. So that's why you write it in these kind of sentences, and this kind of arrow and some conventions are used, and you clearly mention your variable names. So is this simple algorithm clear to you? So we have looked at flowcharts and algorithms. Next, let's look at pseudocode. What does the word pseudo mean to you? Do you guys know the meaning of the word pseudo? The word pseudo means fake or false, right? So this is like fake code, almost like, not the real code. But the advantage is it looks very similar to code, so we can easily translate it to another language. So what exactly is pseudocode? Pseudocode is an informal way. See the keyword here? It is an informal way of describing the steps of a program solution without using a strict programming language syntax. So it says without using a strict programming language syntax. What does this statement mean? So you're not writing real code, because real code, you know, is it has a very strict syntax. If you're writing Python or Java code, you have to write it perfectly correctly, otherwise the compiler will give an error. But this is not like that. This is just writing. This is like pseudocode is more like rough code. Okay, so you're just writing it roughly. So we can say pseudocode is like rough code. You're just writing it informally. The advantage is that you can quickly write it down like, rough code, and then translate it. Once you're satisfied with your logic, now you write the actual code. So it will save you time, because you're not wasting time thinking about the syntax and details of the language. Your focus is on the logic. So that is the whole importance of this class, that when you're learning flowchart, algorithm, pseudocode, your focus is on the logic and not the details and nitty-gritties of the language. Okay, that comes next. You're in the planning stage, right? So same way here, you're saying input radius in variable r. Okay, this is one way of writing. You may see different ways. Sometimes they'll just say input radius comma r, or in variable r, whatever style you're seeing. There are different styles of writing pseudocode, because it's all informal. There's no right or wrong way. Similarly, you can say area equals 3.14 times r times r. So you have clarified you're calculating area, or you can maybe just write capital A, display area. So can you see the logic is very clear, that we are doing input, calculation of area, and display. This is called pseudocode. So are all the three styles clear to you? Flowchart, algorithm, and pseudocode. We'll of course look at some more examples to really understand these concepts. But the whole goal is to plan out your logic, to brainstorm and decide your logic, and especially if the program is complicated. So you do this, and this is what professional programmers do. They plan it out using either flowchart, algorithm, or pseudocode. Then they go to the actual coding, because actual coding takes time. It needs to be perfectly right. But before that, your logic needs to be right. So in summary, this is what we have learned, that using the example of area of a circle, you could use flowchart, algorithm, or pseudocode. So I put them all in one slide for you to see that the whole goal here is to represent the logic. So what we are trying to show here is the logical steps. So flowchart, as you can see, is a pictorial kind of representation. You could write an algorithm, which again has start, stop, but you're writing it in a stepwise fashion, and pseudocode like your rough informal code. So sometimes your school will teach you all these different styles, or sometimes you might be following one style. Many times, sometimes people find it easier to first draw the flowchart, then write the code. Sometimes even some people find it easier to first start off with the code and then start thinking of the flowchart, then again come back to the code. So there's no perfect right or wrong way. It is what style you like. But always they recommend that do not jump to coding first. Do the planning on paper first, or at least in your mind before you go to code. Another very important aspect is verifying your algorithm or your flowchart or your pseudocode. What does this mean? So let's say you have written an algorithm. Now you may think that it's right, and you'll say, okay, I've written my algorithm. Now let's go to the computer and start coding, because we all love to code, right? We want to get our hands on the keyboard and write the code. But wait, there is a smart way to first verify your algorithm on pen and paper, using pen and paper, and then code. So this is what we call as doing a dry run or using trace tables. So what is the meaning of dry run? That the code that you have written, or not exactly the code, the algorithm that you have written, you are doing a check of it on pen and paper before you write the actual code. So how do we do that? Very simple. You become the computer now and go step by step in the algorithm and check if you're getting the desired output. So for example, let's start with step 1. So step 1 is simple, start. Then we say, let's input the radius. So you keep your finger here, you're in step 2, and in the dry run, we'll say, we are going to input the radius. So let's take some example. Let's say the radius is 10. Okay. So we have come to step 2 here. Then step 3, area is 3.14 times 10 times 10. So what is this going to be equal to? 314. Then the next step, step number 4. So please go stepwise. We have finished step 3. We are going to step 4 here now. Step 4 is to print the area. So the computer is going to print 314 here. And then we stop. So can you see the program is working exactly as we expected? Let's say we input 10. It calculated the correct area and printed it out. So this is known as dry run, doing it on pen and paper without the computer. Here, your brain is the computer. So this kind of procedure is called dry run. And the important thing in dry run is make sure you keep your finger or you keep ticking as you are doing these steps. So you keep going step by step so that you do not miss out any single step. Another way is using trace tables. What are trace tables? Trace tables are basically, while you're running the program or while you're doing a run on pen and paper, seeing how the values of the variables are changing. Because you can see the important thing are the variables, radius, then area. These are the important things, right? So what will you do here? So again, you do start, you come to your second step, which is input radius. So you can see that variable and you can say value. So your variable is R. You have created a variable like this, and let's say the input value is 10. So we'll put it in our table here. After that, we move on to step number 3. What is the next variable here? Area. So we'll put the variable A. And what value will it take? 3.14 times 10 times 10. So it takes the value of 314. And then we are printing area. So you can keep an output column here also. So after this stage, the output will be 314. So this is known as trace table, where basically you are seeing that all the variables that are there in your memory, right, or in the computer's memory, what are the values, how are the values changing, and what is the output. So this is how you verify an algorithm very easily using pen and paper without running it on a computer. And it's very important, especially for the complicated ones, to verify it using some simple examples. Sometimes if they have different edge cases or difficult cases, like if let's say some program can take a negative number, then you should try a positive number and a negative number and make sure it works for both cases. It's not good if the program is only working for one case, right? So this is what we call as verifying, checking if your algorithm or your flowchart or your pseudocode. So you can do this for anyone, checking if your algorithm, the step-by-step procedure is right. So now we have learned all about flowchart, algorithm and pseudocode. Are you guys ready to pick up your pen and paper and try these out practically? So let's go ahead and do it. And we'll start off first with the problem. Find the smaller of two numbers. So simple question. Let's say you want to input two numbers from a user. You want to find the smaller one, which basically means the minimum. And now what we are going to do is we are not going to write Java or Python code. We are going to write the recipe using flowchart style, algorithm style and pseudocode. Let's start with flowchart first. So before we look at the flowchart, let's quickly discuss the different types of flowchart symbols. I showed you a simple example. Now let me formally write down the names of these symbols. So this first one, which looks like a rectangle, but it has this kind of curve, so almost looks like an oval, but not really an oval here. This is known as start. It's used for start stop. So it is often called Terminator. Have you guys seen the movie Terminator? I think it's one of my favorite movies, right? It was released, I think, when I was your age or something. So Terminator, these are called terminators because they start and stop the program. Next one, what do we have here? This parallelogram kind of looking thing. What is this known as? So when you have this parallelogram shape, this is for input output, right? This is to do input or output. So this guy is used for input. So it's our input or output box. And the next one here, the rectangle one, remember, which contained the formula. What is this? This is the processing box or computation. So normally we call this the processing box, used for processing. So you must follow these conventions, these symbols. The next one, if you have this diamond shape kind of thing, do you know what is this used for? And we'll be using it in our examples. This is used for condition or decision, a yes, no. So you put your condition inside this and then you can create branches. So this is used for condition or what we call as decision box. Then you have this symbol where you just have a simple circle, this small circle. So these are used as connectors. What is the connector used for? For example, you're writing a flow chart and then you run out of space, right? So you have reached the end of the page. Now you want to continue it to the next page. So how do you do it? You use a connector. So let's say you're writing your flow chart and then you end with this connector and you can label it something like 1 or 2. So you put the number 1 here and in the next page, you continue, you put the connector again, write 1 and then you continue your flowchart. So connector is used to connect flowcharts on different pages. So it's more like, continuing the flowchart. Then you have these arrows. Remember flowchart, the boxes need to be connected with arrows, not with simple straight lines with arrows, because you're showing the flow, the direction of flow of the program. So these are known as arrows which represent flow of control. So these represent for us flow of control. Is our program moving downwards, to the left, to the right? That's how you represent with the arrows. And this last one, remember I use this? This is to write comments or your annotations. So this is used for annotations, comments to your flowchart. So these are the most important ones. There are of course more flowchart boxes and symbols, but these are the most important ones that I've done and we'll be using them today. So are you guys ready to draw the flowchart for find the smaller of the two numbers? So that's our question. So how do we start? Remember, flowchart is simple. It starts with the terminator start. So let's do that first. So we're going to write start. And please put it in this sort of box, right? Now, when you want to find the smaller of two numbers, clearly you need to input two numbers from the user and then find the smaller. So we need to input two things here. So let's make the input box first. So please draw the arrow, and input is shown using this parallelogram kind of symbol. Now you can draw two boxes and write input A and then input B, or you can do a shortcut and simply write input A comma B.
What's the first thing you do when you wake up in the morning? If you're checking your phone, stop that. Instead, try this technique from the Mind Science Eye.
So see, we are trying to do a flowchart like this. Now sometimes you'll see in the books they use all uppercase letters, sometimes lowercase in flowchart, doesn't matter, whatever style you like. So since I've used some lowercase here, I can write start in lowercase as well, just to keep it consistent. And please connect these boxes with the arrows. So our input is done. We have input two numbers A comma B. Now what is the next thing we need to do? We need to find the smaller of two numbers and obviously print it out. So how do we do that? Which symbol should we use here? So now we have to ask a question, who's smaller or who's bigger, right? So we'll use this, decision or condition box. So we're going to use that. So the next thing will be, it will flow into the decision box where we are going to ask the question, is A less than B, and you put a question mark, and then you can draw this decision box around it. Is A less than B? So again, see, written in simple English, right? Not any fancy code. So now if A is less than B, there can only be two answers, either a yes or a no. So from a decision box, you can have a yes or a no. Computer doesn't like maybe and all, right? It's binary, yes or no. So what will you do here? So you can have two things coming out, either a yes or a no. So two things flowing out. Now you could flow the two things out of here as well. So you could have your yes and no here, whatever style you like. So if A is less than B, what value will you print? We want to find the smaller, the minimum number. So obviously we are going to print A. So let's write that down. So once we have this, you're obviously going to, so you'll be printing A. And if the question is A is not less than B, who will you print? Obviously the value of B. Clear? And we put this in parallelograms because we are doing an output now. Now some of you might be wondering, what about the case if A is equal to B? So let's say both of them have the value 10. So let's say A is 10 and B is 10. Where will this flowchart take us? So when you reach this question, is A less than B, is it going to be a yes or a no if both are 10? Because 10 is not less than 10, so obviously the answer is a no. It will go here and it will print B, which is 10. But it doesn't matter whether you print A or B because both are equal, so both are correct. We don't need a third case here because if both the numbers are equal, any one of them is the minimum. See, this is where flowcharts help you. This is where thinking of the logic helps you to make sure your logic is right before you code. And it is clear from here that you are still going to get the correct answer. Now, how do you finish it off? So one way is to write this. So you do a stop here, and similarly you will create a stop here. But is this a good flowchart? No, because there should only be one start and one stop. This is not a good style. Please do not do it. You cannot have two starts, two stops, looks very weird. So what do you do here? You just connect these two. So please do not create two stops. So what you should be doing is just join these two. So the flow of control will go this way, and then you create your stop here. There you go. So this is how we write our flowchart. Is this flowchart absolutely clear to you? Next, we are going to write the algorithm for the same question because we're going to practice all the things. Flowchart, algorithm, pseudocode. So what is the algorithm going to be? So remember, algorithm means step by step, right? Step 1, step 2, step 3. So you need to write it in this style. So please think, how will you write the algorithm? And again, you're sort of writing it in English and expressing the formulas if needed. So in the algorithm, again, we are going to write the step by step because it's a step by step procedure. So step 1, we're going to say start. Sometimes, this start stop is ignored in the algorithm, but better to write it down. So that shows the start of the program. What will be the next step? Input the two numbers a comma b. Now you can write input a, next input b, or you can put it in one line. So you can say input a comma b, or you can even say input two numbers a comma b, right? And then what will be your next step? Step 3, you want to find the smaller of the two numbers. So again here you're going to give the decision. So what are you going to say? If a is less than b, you're going to ask this question, right? Is a less than b? Then print a. Else, or otherwise, right, whatever style you're following, else print b. So this is our decision step. You can see clearly we have written if a is less than b, then print a, otherwise print b. So there you go. That's our algorithm, and then we can end it with step 4, stop. So this is how you write your algorithm. Of course, it could be written in slightly different styles. You may not want to write two numbers. You can just say input a comma b or x comma y, whatever. And this is how you express the if condition. You can put it like this in one line: if this, then this, otherwise, or else do this. So do you guys agree this is the correct algorithm for our required program to find minimum of two numbers? If it was maximum, you will just simply change the sign to greater than. That's it. Now let's try to write the pseudocode. So what is the difference here? So remember, pseudocode is informal way of writing code, right? Where you say things like input radius in variable r, or you can say input two numbers in variables a comma b. Then again you do your whatever computation or decision and do your printouts. So it's an informal way where you're not following any particular language. You're trying to write it in sort of simple English and express some formulas if needed and express your logic. So let's go ahead and write down the pseudocode to find the smaller of two numbers. So here usually we don't write 1, 2, 3. We just simply write the code here. So what will it be? Input two numbers in variables a comma b, or you can use capital A, B notation, whatever you like. So that is your first thing. You have taken care of the input. Now you're going to write that decision. So we write it more like an informal coding style here. So we can say something like if a less than b. If you want, you can put a bracket here as well. So if a is less than b, then what do? Then you print a, or you can write display a, else print b. So this is actually very similar to Python code, except in Python code you have certain colons and stuff. But you can see we are writing our logic in a simple way, not caring are we coding it in Python, C++, Java, or whatever language, right? So we don't care about semicolons and putting all those curly braces for ifs and else. We just write it in a simple logical style. Again, there's no right or wrong way of pseudocode, because remember it is informal way. So your way might be different from mine or what is being taught in your school, but use whatever convention and try to keep it simple and easy to read. Okay, so there we print it out and there you're done. The code is ended here. So that's our logic. You can see we are making the output depending on the condition here. So is this pseudocode simple and easy for you now? So once this pseudocode is written, it's very easy to translate it into real code in a particular language. So those were simple example. That was a simple example. And now let's try a more interesting example which says find the factorial of a number. And again, we're not going to write code. We're going to use flowchart, algorithm, or pseudocode, all the three styles to express the logic here. But first of all, what is factorial of a number? Do you guys know? This is a mathematical term. So what does factorial mean? So factorial is a mathematical term which means that, let's say you want to find factorial of a number 4. So how do we represent it? Factorial of a number, let's say 4 factorial is represented as 4 exclamation, and it basically means 1 multiplied by 2 multiplied by 3 multiplied by 4. So you multiply all the numbers till that number. So 4 factorial is basically 1 times 2 times 3 times 4. So what is the answer going to be? 1 times 2 is 2, 2 times 3 is 6, 6 times 4 is 24. So 4 factorial is 24. Similarly, what is 5 factorial? 5 factorial is going to be 1 times 2 times 3 times 4 times 5. So this is going to be 120. Please multiply and check. This is the meaning of factorial. So if anybody asks you now what is factorial of a number, you know, you keep multiplying the number till you reach it. And obviously you can see the numbers become big because you're multiplying. So 5 factorial is pretty large, 120. So let's see, how will you write a program to find factorial of a number? Obviously you input the number from the user. So let's start off with using flowcharts to think about the logic. So what is the first thing in flowchart? Obviously we will start with start. So we simply write start here. And let's keep this example on the side. So 5 factorial is 1 times 2 times 3 times 4 times 5, which is basically 120. So that you guys remember this example. So first we do start. Then the next thing will be to input the number whose factorial we want to find. Let's call that number n. So the next step in the flowchart will be to input n. So here, for example, I'm using capital letters for variable. Doesn't matter, whatever you want, right? So we are going to input the number n. Now once we have input the number n, what do we need to do? We need to multiply all the numbers from 1 to n. Yes, 1 times 2 times 3 times 4 and keep on going till n. So how do we keep on going? Because we need to start from 1, that means we need another variable to keep as a counter. Do you guys agree? So basically we can think of, we need a variable, let's say I, which goes from 1, 2, 3 all the way till n. So this I is basically changing. Yes. And then we are storing that multiplication, let's say in the factorial of the number, which we can call as f. This stores the factorial. So when you're multiplying the number, it keeps storing that. So for example, if you have multiplied till 3, it stores it till here. Yes. So after we do the input, what is the next step? We are going to create these variables. I is 1 because we start from 1. And this factorial, which is going to save the factorial, since we are doing a product, just like if you want to find sum of numbers, what does the sum start off with? 0. But now we are doing a product. If you start off with the initial value is 0, whatever you multiply, it's going to be 0. So be careful here. So our other variable f will also be 1. So this is our processing box because we have not taken these as input. These are the computer variables. Now what is the next thing you'll do here? So to calculate the factorial, what will be the formula? The factorial is basically the current factorial times the next number I. If you look at the logic here, so suppose you are doing 1 times 2 times 3, so you keep stored that in f, then you multiply it by 4, then again you store that in f, multiply it by 5. So can you see the formula just like sum equals sum plus I? Let's say you want to find the sum of numbers, just like sum equals sum plus I. This is to find the sum of different numbers. To find the product, what will you do? F equals f times I. Okay, same logic here. So what we are going to do over here, f equals f multiplied by I. But now what is the next step? You need to keep on increasing the value of I. 1, 2, 3, 4, 5. So I just started off with 1. So what is the next thing we are going to do? We are going to say I equals I plus 1. That means increase the value of I. Now what do you do? So once you have increased the value of I, you want to go back to the formula. You want to loop back and go here and keep doing this. But if this is your logic, the problem is you are never stopping. Can you see? You are in an infinite loop here. You are not stopping based on the value of I. When should you stop? When you have reached n, because you need to do the multiplication 1, 2, 3, 4, 5 till n. So you need to ask yourself the question. You cannot simply loop back here. We need to ask ourselves the question, after increasing I, is I greater than n? So ask yourself this question, is it greater than n? If the answer is yes, or if the answer is no, then you simply loop back. So you're allowed to go back and continue this multiplication. So if your answer is no, you're going to do this. But if your answer is yes, I am greater than n, then what happens? You will simply come out, right? You will come out of this loop and see, since I've run out of space, maybe I can use a connector here. So I can call this connector 1. And finally, we will print the value of the factorial f, which is stored in the variable f, and then we will end the program. See, I'm checking I should continue to be n, right? So let's check if our flowchart is correct. So for example, let's do a dry run here and see this. So let's say we start off with I equal to 1 and factorial f is also 1. So then what happens? In numbers 5. So first time what is going to happen? F equals f times I. So 1 times 1, it remains 1. Next time I equals I plus 1. I becomes 2. So it asks the question, is 2 greater than n, which is 5? The answer is no. It goes back. So now the factorial becomes factorial times I. So 1 times 2, factorial becomes 2. Then again we do I equals I plus 1. I becomes 3. Again we ask the question, is 3 greater than n? No. We loop back. So factorial becomes 2 times I. 2 times 3, 6. Again we do I equals I plus 1. I becomes 4. Again 4 is not greater than 5. So we loop back. Factorial is factorial times I. So what do we do? 6 times 4, 24. I equals I plus 1. I becomes 5. Again we ask the question, is 5 greater than 5? No. So we go back. Factorial is factorial times I. 24 times 5, 120. Again it says I equals I plus 1. I becomes 6. This time 6 is greater than 5, so it will come out. It prints the last value of the factorial, which is 120. As you can see, 120 is the value here. That will get printed out and then we stop. So can you see, we did our test run and it worked out perfectly. So your condition is very important. You need to check, is it greater than n? Then only we stop. If it's equal to n, we let it go because we want that multiplied here. So is this flowchart clear to you guys? Now similarly, if you have to write the algorithm for finding the factorial, so how do you guys do it? Again, this is step by step. So we will write down the steps here. So for example, step 1, start. Step 2 is input your number whose factorial you want to find. Step 3, you assign these values, I equal to 1, f equal to 1. If you want, you can break this down into 2 steps where you're doing this initial assignments. Okay. Sometimes we said when we are showing assignments in this algorithm, we tend to show it with the arrow. So whichever style you want to follow. Then what is the next thing we need to do? Now we need to write the formula to find the factorial. Factorial is you multiply the current value with the next I. So we're going to write the formula. Step 4. Factorial f is f, the current factorial, multiplied by the next number I. So we did that. Next step will be to increase the value of I. Yes. Or another thing we could have done is we could have checked the value before increasing it. So it depends on how you're writing the loop. So here we can do I equals I plus 1, which means increase the value of I and then put it back in I. Now what will step 6 be? As long as your value of I is less than or equal to n. So what can we say here? While I is less than equal to n, you need to keep repeating these steps, right? So as long as I less than equal to n, you repeat steps 4 to 5 or 4, 5, 6, right? So while I is less than equal to n, repeat your steps 4, 5 and 6. So see, algorithm helps us to tell which steps to repeat. This multiplication step, increment step, and again the checking step. So keep doing this, and then once it is more than n, obviously we will come out, and please don't forget to print the value of the factorial. So we'll print out f, and step 8 is stop. So there you can see we have written the algorithm of the same program. The whole logic is, so the whole trick in factorial is you keep multiplying the number with the next I. So just like, when you're finding 4 factorial, what do? 1 times 2, see, times the next number, 3 times the next number, 4. So same logic here, you keep multiplying it with the next number, keep incrementing your I, and do this, repeat these steps 4, 5 and 6 as long as your I is less than equal to your number n. The moment I becomes bigger, you print out the thing and you end the program. This is how you write the algorithm. So yes, I think many of you might be thinking flowchart is easier. Definitely, because it's a graphical, pictorial representation. But the problem is, you have to draw these boxes, all these arrows. So it's a little more time consuming, but definitely more visual than writing these steps. And last thing we're going to try is writing the pseudocode of the same question so that we are clear about all the styles and you can decide which style you like. So in pseudocode, remember what was it like? Pseudocode looks like a program, right? Informal program. So let's go ahead and write that. So pseudocode of our factorial is going to look like, so what is the first thing you're going to do? Input number in variable n. Again, you can use small or capital depending on the convention. So here I'm using a capital just to keep it consistent. So capital N is our number whose factorial we want to find. So what will be the next step? So we will of course assign we will say I equals 1 and our factorial is 1. You can break this down into separate lines also if you want. So what is the next thing you're going to do? So basically you need to do the check that as long as I is less than n. So you can say while I is less than equal to n. So in this kind of style you might be thinking of writing the check first. In flowchart we wrote the check later. So it depends on your logic, right? How you're writing it. So here you're saying that your first checking is your number less than equal to n. As long as I is less than equal to n, you will continue doing this. So in the factorial, you will multiply f equals f times I and I equals I plus 1. Okay, so these you're doing inside this while condition and sort of your while loop ends here. So you can write end of while. Again, this is informal style to show that this is where my condition or looping started. So you can see clearly there's a loop thing here because you're repeatedly doing the steps. So can you guys see that we are in a loop? Just like we say playing a song in a loop, repeatedly playing it. So repeatedly you're doing the steps, but it's not an infinite loop. You're not going on and on. There is some condition here. Similarly in the algorithm, you can see there is a loop here because we are saying repeat the steps 4, 5, 6 as long as this condition is true. Same thing we are saying here. Can you see there is a while, there's a kind of a looping thing here going on. But keep doing this as long as I is less than equal to n. And then you come out of that. Once you come out of your condition, what will you do? You're going to display or print the value of not I, the factorial f, and that's when you stop your program. Okay, so again you can see the nice part about this is quick code, rough code, but it is very close to almost writing the code. So pseudocode, the advantage is that you can quickly translate it into Java or Python code because you have almost written code. Okay. Algorithm, the advantage is it's very clear step by step, right? You have outlined all the steps in a systematic fashion, and you can easily address the step using their step numbers. And flowchart, of course, a lot of hard work drawing all these boxes, but very visual and pictorial, and you can clearly see the flow control. So that's why I always remember to put the arrows. So which one did you like? Flowchart, algorithm, or pseudocode? What is your favorite here? So here you can see this is the summary slide like we discussed. We have discussed all the different ways of putting down or writing our logic. We can use flowcharts like this. We can write it in a algorithm step-by-step style, or we can write this informal pseudocode. But good idea to practice all of this. And of course, when you're doing, you're writing a real program, you can follow the one which is your favorite, which one you like, whether you like drawing a flowchart like this, or writing down an algorithm, or writing in terms of pseudocode. But the goal here is to brainstorm and get your logic right. And as I showed you, you can do a dry run or use truth tables and verify on pen and paper that yes, my logic is right. So you're confident before you sit down for your actual coding. Because coding is time consuming, you have to write it perfectly, and when you run it and then you see it's not working, it feels disheartening. So that's why plan and get your logic right first and then go to the coding step. So hope you guys enjoyed this class where we learned all about flowcharts, algorithms, and pseudocode. Very, very important class in computers. So now you guys can think like a real programmer, like a real coder, and become more expert at programming.
Bien, jóvenes, me gustaría saber si alguien tiene alguna pregunta acerca del video que recién acaba de ver. Me interesa ahorita
Ningún ingeniero.
Gracias, Carlos. Me interesa ahorita la parte de los diagramas de flujo. Él en el video, pues, o sea, va mostrando las equivalencias entre un diagrama de flujo, un algoritmo y un pseudocódigo. De aquí en adelante nosotros vamos a enfocar un poquito en el diagrama de flujo y posteriormente al pseudocódigo, porque eso ya nos va a permitir movernos hacia un lenguaje de programación. Entre los ejemplos que él hizo, él ahí hizo un diagrama de flujo para identificar el mayor de dos números. ¿Sí? Entonces, todo lo vieron ahí. También mostró cómo calcular un número factorial. Entonces, me gustaría que en base a lo que vieron, a los diagramas de flujo, me construyan un diagrama de flujo para determinar el mayor y menor de 10 números. El ejemplo lo hizo con 2. Yo quiero con 10 números. Quiero que lo visualicen y primero hagan su dibujo y después plásmenlo en el diagrama de flujo. El diagrama de flujo, como lo decía, es una herramienta muy útil, muy gráfica, fácil de que se entienda lo que uno quiere hacer. Así que espero que sea una herramienta que ustedes usen de aquí en adelante pues, en todo lo que hagan ustedes y que tenga que ver con una solución informática. Entonces, pónganle ahorita atención a eso. Un diagrama de flujo para determinar el mayor y menor de 10 números. O sea, se van a ingresar 10 números y ustedes deben determinar de esos 10 el mayor y el menor. Los dejo entonces, jóvenes. Trabájenlo, por favor.
Perdón, ingeniero, esto es en diagrama de flujo.
Así es, diagrama de flujo.
Ok, gracias.
Muy bien. Ok, jóvenes, llévense el ejercicio, termínenlo y lo vemos el día de mañana. El día de mañana tenemos viernes alterno, así que aprovechamos para hacer ya unos ejercicios y de paso revisamos cómo les queda este. Por favor, háganlo. Yo sé que por ahí ustedes pueden encontrar una solución para esto que ya esté hecha, pero lo importante es que uno lo haga, ¿ya? O sea, si ustedes lo hacen, pues van a aprender, que eso es de lo que se trata. Mientras que si se copia, pues ahí no se aprende nada. Aunque uno crea que va a revisar la solución y con eso va a aprender, es mentira. O sea, en el tema de algoritmos, al igual que en la matemática, hasta que uno resuelve las cosas por sí mismo, entonces cuando uno realmente aprende. Bien, jóvenes, les deseo feliz día entonces y si Dios lo permite, nos vemos el día de mañana. Pasen a bien.
Feliz día, licenciado.
Feliz día, ingeniero.
Día.
Feliz día.